Today's lesson will be a review for comparing numbers in scientific notation. Compare the two values using a greater than, less than, or equal sign. So we're comparing these two numbers in blue. 5.2 times 10 to the 5th, comparing it to 7.8 times 10 to the 4th. We should know the things that we need to look at. There are two different things we need to look at. The very first thing is looking at our exponent. We have a 5 and a 4. There's a difference there. So this tells us, and assuming that these are all in scientific notation, that's the very first thing. Make sure that these two numbers are in scientific notation. So, or at least the same form. It's either standard form or scientific notation. In this case, we're going to be talking about scientific notation. So converting everything to scientific notation in the correct form. So 5.2, the coefficient's fine. 7.8, the coefficient's fine. So let's look at our exponent. The exponent of 5 is greater than the exponent of 4, so the coefficients don't even really matter. So that's the very first thing you look at, is check to see if they're in scientific notation, the correct form. Then look at your exponents. If they're different, pick the larger one. So 5.2 times 10 to the 5th is greater than 7.8 times 10 to the 4th. Okay, look at our second one. 3.4 times 10 to the 7th is compared to 9.99 times 10 to the 7th. So we look at our, see if it's in scientific notation. Correct, yes, good coefficients on both of them. Then we look at our exponents, they're both 7. Okay, that doesn't help us. So now we have to look at our coefficients. 3.4, 9.99. So the exponents are equal, so you need to compare the coefficients. So when we're looking at this, 9 is bigger than 3. So how we'd say this is 3.4 times 10 to the 7th is less than 9.99 times 10 to the 7th. As a little review, for greater than and less than, remember it kind of looks like an alligator. Alligator's going to eat the bigger number. So looking at our last example on this page, 6.04 times 10 to the negative 4th, comparing it with 0. So what we need to first look at is it in scientific notation? Yep, they both are. And we should notice that the coefficient of this first number is positive. So the value of that number is going to be positive. So yes, our exponent is negative, but that's just telling us we're moving our decimal 4 places to the left. And if we did that, we're moving it 1, and then we're going to add 3 more zeros. Is that number still positive? It sure is. It's a small number, but is it more than 0? It sure is. So 6.04 times 10 to the negative 4th is greater than 0. Let's take a look at these three examples. Greater than, less than, or equal. 5.2 times 10 to the 5th, comparing it with 520,000. So the very first thing we need to do is convert the second number to scientific notation. We need to move our decimal. Our decimal's right here. We're going to move it 5 places to the left. So if we did that, it's 1, 2, 3, 4, 5. So we're putting this in scientific notation. So 5.2, since we moved it 5 places left, it's going to be to the 5th power. So they're going to be equal. So remember, our exponent will be positive because this number is huge, right? It's bigger than 1. So then our exponent is going to be positive. Or I should say bigger than 0. So our exponent's going to be positive. All right, let's look at this one. We have 3.4 times 10 to the negative 10th and 3.4 times 10 to the negative 8th. So we look at is it in proper form? Yep, good coefficient. It has a whole number for an exponent. Both of them work out fine. Now we look at, the very first thing was look at our exponents. We have a negative 10, negative 8. They're different. Which one's bigger? Negative 10 is less than negative 8, so the coefficients don't even really matter. So 3.4 times 10 to the negative 8th is bigger than this one. So our answer would be 3.4 times 10 to the negative 10th is less than 3.4 times 10 to the negative 8th. If you think of this as your number line, negative 10 is further away from 0 than negative 8. Negative 8 is closer to 0. That's why it's larger. Okay, 6.23 times 10 to the 4th comparing it with 6.234 times 10 to the fourth. So we make sure that these are in scientific notation. Yes, the coefficients work. Coefficient works. Whole number for exponent. Whole number for exponent works out. So let's check our exponents. They're the same, 4 and 4. So then we have to look at our coefficients and determine which one's bigger. We have 6, 6, 2, 2, 3, 3, and then we have nothing here, so we assume it's a 0, and we have a 4. This one, our second one, is going to be bigger. Place a 0 in that thousands place of the coefficient, so 230,000 is less than 234 thousandths. All right, so how we'd say this, 6.23 times 10 to the fourth is less than 6.234 times 10 to the fourth. All right, I hope we're starting to get this. Now we're going to ask you to put these 7 numbers in order from least to greatest, or smallest to biggest. So we have the very first thing that you should do is put these in scientific notation. Get them all in the same form. So scientific notation, these two are good. This one we need to convert, and this one's good. This one we need to convert, and 0, 0. So we can just keep that the way it is. So when we're trying to figure these out, is none of these numbers are negative, so none of these numbers are less than 0. So therefore, 0 is the number with the least value on this list. So that one's going to be listed first. All right, so that's eliminated. Then let's take a look at our next smallest one. So if we know this was going to be, we're moving our decimal to here, 3.7, and we're moving a total of 1, 2, 3, 4 places. So it's going to be 3.7 times 10 to the fourth. And this one, we're moving to the right, so it's going to be 1, 2, 3, 4. So 3.7 times 10 to the negative fourth. So there are 2 numbers on the list that are less than 1. Those have to come next. So let's look at comparing those 2 that are less than 1. So these 2 are going to be less than 1 because this negative exponent is telling us we need to move our decimal 1, 2, 3 places. So when we convert this, when we convert our bottom one, which I mentioned before, we convert it to 3.7 times 10 to the negative fourth. So negative 4 is further away than this negative 3, being that they're at 3.7. We're comparing the 2. So our next smallest will be this 3.7 times 10 to the negative fourth, which in the example that they gave is this number 0.00037. That's going to be our next smallest. Our next biggest will be 3.7 times negative to the negative third. All right, so we're down to these 3. And what we need to do next we need to order the numbers with positive exponents from least to greatest. So let's do that. If we were going to look at these 3.7, this would be times 10 to the 0 power because we're not moving it. So 3.7 to the 0 power would be our scientific notation for this one. If we wanted, so that's going to be our next smallest. Then we look at 3.7 to the first power, so because 1 is bigger than 0. So we have left to compare would be these 2. And like I mentioned before, this would be 3.7 times 10 to the 1, 2, 3, 4th power. So that would go next, 3.7 times 10 to the 4th. And our last one, 3.7 times 10 to the 5th, would be our largest number in this problem. That is in this example. All right, let's try these. Once again, we're asking you to go from least to greatest. And we have to convert a few numbers into scientific notation. So then it's all apples to apples. So here we go. The very first thing that you should look at are numbers that are first, start with negative exponents. The coefficient doesn't matter because all the exponents are different. Order the negative exponents from least to greatest. So if we did that, we have 3 different negative exponents. We have this 9.2 to the negative 4th, 7.4 to the negative 2nd, and being that this number is, we have a 0 in front, we know that's going to be a negative exponent. So if we had to convert this 0.0024 into scientific notation, it'd be 2.4 times 10 to the negative 3rd, because we moved it 1, 2, 3 place values. So negative 3 is bigger than negative 4. So our smallest number is 9.2 times negative 4 times 10 to the negative 4th. Then it's going to be 2.4 times 10 to the negative 3rd. Then we have this negative 2 would be our next biggest, 7.4 times 10 to the negative 2nd. Notice we didn't even bother looking at the coefficients, the numbers in front, because all our negative exponents were different. All right, our next thing that we need to do is order the numbers with positive exponents from least to greatest. And we're going to look at those exponents. So this 35,000 would have a positive exponent. It would actually be 3.5 times 10 to the 4th, because it's 1, 2, 3, 4. So we have it to the 4th power. This one, we have to move our decimal 1 place in. So this would be to the 1st power. And this one, oh, I skipped one. This one's already to the 5th power. And this one's to the 5th power. So our next thing that we really need to do is, since this is 4.5 times to the 10 to the 1st, that's our look at our exponent of 1. Then we have this 35,000, which is 3.5 times 10 to the 4th. Notice our exponent of 4. And all we have left are these exponents of 5. So, and they're in, both of them are in correct scientific notation. So then we look at our coefficient. 6.8 is smaller than 8.9. So 6.8 times 10 to the 5th and 8.9 times 10 to the 5th would be round out our problem. Put them in order. All right. And that concludes our review today. Please email your teacher if you have any questions.